Hi, you're watching UseWise YouTube channel. I'm Adriana Baranek, CEO of Media Group, and here with me is Martin Baranek, our CDO.
Hi.
Basically, we often talked about artificial intelligence in various contexts, and we decided to make 3 videos. The video today is the first one about what are machine learning, deep learning, and neural networks, and how do they relate to AI? Because this is frequently a point of confusion, and people often do not understand the difference between those 3 terms and how they relate to artificial intelligence. So today we're talking about machine learning. Martin, can you tell us more about it?
So, first of all, artificial intelligence is a broader term that encompasses machine learning. So, artificial intelligence itself, it can be divided in 3 categories. One is narrow artificial intelligence that includes machine learning, and it is domain-specific solution for specific problems that may look like humans are on the other side. So there is some intelligence in solving those problems. Then there is a kind of general artificial intelligence where basically you need capabilities to act as a human being. So the idea is you wouldn't be limited with a specific problem domain. You would possess intelligence of a human to solve problems that are not related. And the third category is super intelligence. That is basically when whole humankind or even more capabilities would be required to solve specific solve problems. So super intelligence is something that is beyond the reach of our human understanding. So machine learning is a part of this narrow artificial intelligence, where the idea is you would actually use some data sets and you would try to extract algorithms from those data set in a way that you can solve problems. So examples are, for example, optical character recognition is one perfect example of machine learning algorithms, where you have a specific task and you can teach your machine learning algorithm to recognize specific letters. Of course, it can be used for natural language processing and image recognition and stuff like that, but it is not really something that will present itself as a human if you go outside of a specific domain for which machine learning algorithm is trained. So there are a number of problems that can be solved by algorithms, and then you don't need artificial intelligence or whatever, like sorting or stuff that can be done in a limited amount of time, and that we fully understand. But there are problems where we know there is a solution, but unfortunately, if we try to calculate all possible cases, like for example, game of chess or recognizing images on certain screen, then basically you have so many combinations that you cannot do it in real time, and usually you cannot solve such problems at all. So there are a number of heuristical methods how you can suboptimally get to a solution. So, of course, if you are, for example, using optical character recognition, it will not be 100% perfect, but you will get very close to 100%.
Yeah.
And the way how you build your algorithm is what makes machine learning. So you start with a certain data set, then you control how your algorithm will learn whether it recognized letter or not. And as Adriana asked, there are certain methods that can be used. So there are a number of algorithms, but neural networks and deep learning comes from the idea that we would try to emulate how our brains work. So in 60s, people had the idea, okay, we'll invite mathematicians and some very clever people, so we'll figure out how human brain works, and we are going to translate Russian to English and English to Russian. So it will not be a problem. Basically, human brain is quite simple. So you just implement few algorithms, and with computers you'll be able to do it. And after a few months, there was a clear understanding that it's a little bit more complex than that. So even natural language processing, that was a requirement of 60s, was beyond capabilities of computers at that time. Plus, there was no understanding how to solve that problem at all. So with this general idea of neural networks and how we can approach machine learning or using such algorithms, only 10 20 years ago was natural language processing possible, and today we can obviously use it. So everybody is using Google Translate to translate between different languages, and we can also gain some understanding, semantics, and yeah. So the idea is machine learning is a very narrow, I would say, beginner step of artificial intelligence that can yield some algorithms we can use in our everyday life to solve specific domain problems like image recognition or even natural language processing. So
Yeah, because very often people confuse those things, and sometimes they claim that they're using artificial intelligence when what they're doing, in fact, has nothing to do with machine learning or artificial intelligence. And the fact is that, in a way, machine learning is the beginner step. And it is very important to note that public cloud is essential in using all those technologies. Can you tell us more about that, how you can start using machine learning in the public cloud?
So within public cloud, you have a platform as a service solutions where you can actually start with already prepared data sets. You can reuse some of machine learning results that are already pre-processed and prepared, and then you can improve
Yeah.
improve on them to solve your specific need. So in many cases, using a public cloud for machine learning gives you both capacity and prepared solutions that you don't waste your time and resources if you would like to start using a machine learning. So of course there are other algorithms, not machine learning algorithms, that can usually be applied for such problems. So one example is brute force, where you just generate all possible cases and you calculate final result, and then you get your solution. So it is possible to do it for tic-tac-toe and very simple games. Of course, it's not possible to do it for chess, because chess has too many possible combinations, and it is just not possible to calculate optimal solution for every possible move you can make in chess. But there are, for example, for image recognition, a number of other algorithms that are usually performing quite okay, so you do not have to resort to machine learning. But in public cloud, you also have those machine learning algorithms with data set and all capabilities needed to train for your specific requirement.
Yeah. And this is definitely an area that can be used even more by companies and give them even bigger strategic and market advantage than using just the ordinary old school on-premise technology.
Yes.
So basically, is there anything else that you would like to add? This is again such a huge topic, but
so with public cloud and machine learning, there are a number of use cases, from implementing IoT to using, for example, Alexa or Google Home or such devices, where you can actually implement assistants in I don't know, rooms for elderly and stuff like that. So there are number of applications of artificial intelligence where you can, for example, provide hotline service or reception service for elderly people, so they don't have to rely on phone. They can just call for help, and Alexa might be able to actually recognize that and immediately invite people to solve problem.
Yeah, and if you would like our help, please contact us. We have office hours on Friday. They're free, and we would be happy to speak with you and to see what is of interest to you regarding the machine learning. We will be continuing this conversation in next two videos, and it was very interesting, Mladen, I must say. Even though Mladen is my husband and our CTO, I always hear something new whenever he tells and covers some topics.
Yep. Thank you for watching us, and have a nice day.
Yeah, thank you for watching us. Have a nice day, and subscribe and like us. Thank you. Bye.
Bye.
Bye.